In this video, we'll take a look at how to calculate the correlation coefficient in SPSS. Now, when we talk about calculating correlation, what we mean here is Pearson correlation. While there are other correlation coefficients, by far Pearson correlation is the most common correlation coefficient that's used, and it's the one that's included in introductory statistics texts. Sometimes there are other correlation coefficients as well, such as Spearman's rho, but Pearson's is the one that's focused on in nearly every text out there. The Pearson correlation measures the degree of the linear relationship between two variables. When we say linear, what we mean is that the relationship can be well characterized by a straight line. So a straight line does a good job at representing the relationship. And towards the end of this video, after we run the correlation, we'll create a couple of scatter plots to give you a better idea of what we mean when we say well characterized by a straight line. A correlation ranges from negative 1.0 to positive 1.0. And Pearson correlation is given by the letter R. And as an example, you might see something reported like R equals 0.55. Notice that this value of 0.55 ranges from negative 1 to positive 1. It's in that range. You should never see a correlation of 1.2, for example, above this value, and you should never see a correlation of negative 1.8, for example. Those both would indicate mistakes. So if you ever calculate and get an answer that's outside of this range, or you ever see someone report an answer outside of this range, something's wrong, so you should take a second look at your values. There are three types of relationships I'd like to talk about with Pearson correlation. And in this description, we have two variables. The first variable is x, and the second variable is y. So our first type of relationship is a positive relationship. And for a positive relationship, or a positive correlation, that's saying the same thing, higher scores on x are associated with higher scores on y. And what this means is there's a tendency for if an individual has a high score on X, they're also going to tend to have a high score on Y. It's not necessarily perfect, in most cases it won't be, but if you know someone's score on X, it gives you a good idea of where they are on Y. High on X, high on Y. For positive, it's also true that if you have a lower score on X, you would tend to have a lower score on Y. The second type of relationship is a negative relationship or negative correlation. Now here we see the opposite pattern. So here, higher scores on X are associated with lower scores on Y, and vice versa. Lower scores on X are associated with higher scores on Y. So this is an opposite pattern. Higher on X goes with lower on Y, lower on X goes with higher on Y. Finally, our last type of relationship is no relationship, and that means there's no predictable relationship between X and Y. And another way to think about it is, where here we had higher on X, we had higher on Y for positive, and for negative we had higher on X was lower on Y. Well, for no relationship, we have, if you have a low X, you're going to have some low Y's, some medium Y's, and some high Y's. If you have a high X, you're going to once again have some low Y's, medium Y's, and high Y's. There's no relationship, no predictable relationship between X and Y for a correlation that exhibits no relationship at all between the two variables. Okay, with the background of correlation laid out, let's go ahead and take a look at our example. In this example, we have the following two variables, hours of media or hours media and college GPA. And what we did here in this hypothetical example is we recorded the number of hours of media during a given week that individuals engaged in, and media could be TV, movies, internet, and so on. So we recorded the number of hours of media that people engaged in a given week, and then we also obtained their college GPA. And we want to see if there's a relationship between these two variables, as measured by Pearson's R, our correlation. And if you think about it, if somebody watches a lot of media, so they're spending, let's say, an inordinate amount of time watching media, whatever form it may take, that's not going to leave them probably sufficient time to attend to their studies. And in that case, if we had a lot of hours of media watched, that probably would suggest that the GPA may be lower. Now, this may or may not be the case. We'll see what happens in this example. But if that was true, high hours media, low GPA. Do you recall what kind of correlation coefficient that would be? Well, if we use the generic variables X and Y here, high on X, low on Y. So it's an opposite pattern, high on one, low on the other. That, you may recall, is a negative correlation. So it makes sense, at least theoretically speaking, that there could be a negative correlation here. But let's go ahead and run the analysis and see what we find. To run the correlation, we go to Analyze, and then Correlate, and then Bivariate. And bivariate, if you think about it, bi just means two, and variate is just another name for a variable. So this is the correlation we use when we have two variables, like we do here. So select bivariate, And then here notice hours media and college GPA are on the left-hand side here of our bivariate correlations box. You should see on your screen hours media is already selected, so go ahead and click the right arrow button to move it to the variables box. And then select college GPA and click the right arrow button once again to move it over as well. Now notice here under correlation coefficients that Pearson is chosen by default. That's Pearson's R, that's what we want to run here in this analysis. If you wanted to run something like, say, Spearman's, you could check that box. But what we want to run is the Pearson correlation, which is the most commonly used correlation coefficient by far. So that looks good, Pearson is selected, everything else looks great, let's go ahead and click OK. And when we click OK, the correlation analysis is presented in our output here. And the way you read this here is you want to see where hours media and college GPA meet or intersect. So these two variables, if you see, they meet right here in this box here. And it's also shown here once again as it's redundant. So either box is fine to look at. Notice that our correlation, where it's shown here as Pearson correlation, is negative, so it is negative, 0.66 if I round to 2 decimal places. And then the p-value is 0.001. So using an alpha of 0.05 and a two-tailed test, where a two-tailed test allows for a positive correlation or a negative correlation, we can use the following decision rule as we have for all of our tests. If p is less than or equal to 0.05, the test is significant, which here would indicate that there is a significant relationship between hours of media watched and college GPA. Whereas if p is greater than 0.05, the test is not significant, indicating that there is not a significant relationship between hours of media watched and college GPA. Our p-value in our output is once again 0.001, so applying the p-value to our decision rule, we can see that 0.001 is in fact less than 0.05, which indicates the test is significant. In other words, in our example, there is a significant relationship between hours of media watched and college GPA. Next, we'll write our results using APA format. We could write our results as follows. There's a significant negative relationship between hours of media watched and college GPA. And then we have R, which is for Pearson's R. We have 18 degrees of freedom. Now, the degrees of freedom, interestingly, are not reported in this table here. Instead, we just get an N. But the degrees of freedom for Pearson's R are equal to the total number of people in your study, or your sample size, minus 2. So N minus 2. Well, if we have 20 people, N minus 2, or 20 minus 2, is 18. So that's where I got this here. Next, we have a correlation coefficient of negative 0.66, which you can see in the output here when we round to 2 decimal places. And then we have a p-value of 0.001, which is shown in our table here. Notice as well in the output here that SPSS uses asterisks to indicate if the test is significant. And it might be a little hard to see, but there are 2 asterisks here. And notice the note down here where the 2 asterisks are showing, and it says correlation is significant at the 0.01 level, two-tailed. Now if you saw 1 asterisk showing instead of 2, this would read correlation is significant at the 0.05 level, two-tailed. And it's just the way SPSS outputs it by default to make it a little more user-friendly. We could turn that off if we wanted to in the bivariate correlations box, but we just left it as is. I had indicated earlier that I would show you what the linear relationship looks like, so let's go ahead and spend a few moments doing that now. And what I'll do is I'll go ahead and graph the relationship between hours media and college GPA for our 20 people. So to do that, we want to go to Graphs, and then go to Legacy Dialogs, and then down here towards the bottom, select Scatter Dot. And then notice Simple Scatter has the box around it. We want to go ahead and go with this default option. So go ahead and click Define. And then here, I'll put college GPA in my y-axis box, and I'll put hours media in my x-axis box. Now, if you wanted to, you could put hours media in the y-axis and college GPA in the x-axis. In other words, flip these variables, and that would be fine as well. Next, we'll click OK. And then here we get a graph, which is output. And notice here I have all these circles here. There are actually 20 of these circles here, where each circle represents the values for a given individual in my data set. And the way to read this is, if I double-click this for a moment, this circle here, notice how on my x-axis variable, the horizontal axis, which we also can think of as x, this is labeled hours media. So here is my hours media variable. And over here, this circle, notice it looks like it's about 30 hours of media, this individual. This is one person's score on hours of media, how much media they watched. And then if you scroll over here to the y-axis, labeled college GPA, we can see that their GPA was somewhere around more or less 2.3, maybe 2.35, but somewhere in there. So this point here is high on hours of media, if you notice that. They're all the way to the right, but they're low on college GPA as they're way down here. These other 2 points are high on hours media, but they're low on college GPA. Next, notice these points over here. This point is low on hours media. They're somewhere around 7 or so, but they're high on GPA. If you notice, they're close to 4. This person is fairly low on hours media, and they're fairly high on GPA, and so on. And then these people in the middle, they're moderate on hours of media, and they're moderate on their GPA, as far as our GPA was measured, which is about from 2 to 4 here. Notice this characterizes a negative relationship. High on one variable, low on the other. Or low on that variable, high on the other. That's how we define a negative relationship. And there's one last thing we can do here. If we right-click this plot, and a shortcut menu opens here, and if we go ahead and select Add Fit Line at Total, click on that. And then here, we're going to select Linear, and then close, and you'll see here this line, which is used to represent or fit the data points in general. And notice that a straight line is applied. This is exactly what we're doing here with Pearson correlation. We're using a correlation that estimates the linear or straight line relationship. And these points, they do a pretty good job of fitting a straight line here, as opposed to a situation where we don't have a linear relationship. And if you think of something like a parabola, if we had dots like this, and they came around like a horseshoe or a U upside down, that would be a non-linear relationship, and we would not want to use Pearson's R for that. But in many situations, our points do fall in a pattern that mimics a straight line relationship, as opposed to some non-linear relationship like a parabola. This concludes the presentation on correlation in SPSS. Thanks for watching.